DeepSeek's bold move, 300 new jobs created in semiconductor sector to fuel AI chip innovation. Overview. In a significant development for the Chinese technology landscape, DeepSeek, a rising star in the artificial intelligence AI sector, announced the creation of 300 new jobs within the semiconductor industry to bolster its operations and innovation in AI chip development. This move comes on the heels of DeepSeek's launch of its R1 large language model LLM in January 2025, which has garnered immense attention for its groundbreaking capabilities and competitive pricing, positioning it as a formidable contender against established U.S. firms like OpenAI. The launch of DeepSeek's R1 model. On January 20, 2025, DeepSeek officially unveiled its R1 model, which quickly disrupted the AI market by offering performance comparable to OpenAI's products at a fraction of the cost, between 20 to 50 times cheaper depending on the application. This dramatic price reduction has raised eyebrows in the tech community, prompting U.S. President Donald Trump to label the launch a wake-up call for American tech firms. The immediate aftermath saw a notable decline in Nvidia's stock prices, reflecting investor concerns over increased competition from DeepSeek. Impact and reactions. The launch of the R1 model has not only altered market dynamics but has also invigorated investor sentiment towards China's tech sector. Analysts indicate that DeepSeek's success could encourage further innovation within the private sector, as it demonstrates the potential for competitive AI development absent significant government backing. Provincial support from Zhejiang, where DeepSeek is headquartered, has further fueled ambitions to establish the region as a global hub for AI and advanced technologies. Local government officials have pledged to enhance support for AI industries, targeting a combined computing capacity of no less than 100 EFLOPS by the end of 2025. This ambition aligns with broader national objectives to elevate China's technological prowess. Job creation in the semiconductor sector. In response to the burgeoning demand for AI innovations and the need for advanced semiconductor technologies, DeepSeek's recent announcement to create 300 new jobs in the semiconductor sector is pivotal. This initiative aims to strengthen the supply chain for its AI chips and ensure that the company maintains its competitive edge in the rapidly evolving landscape of AI technologies. DeepSeek's focus on semiconductor development is particularly timely as the company seeks to mitigate the impacts of U.S. export restrictions on advanced technology by investing in local semiconductor capabilities. DeepSeek not only aims to reduce dependency on foreign suppliers but also to cultivate a skilled workforce capable of driving innovation in chip design and manufacturing. Geopolitical context. The backdrop of DeepSeek's rise is steeped in the ongoing U.S. China tech rivalry, marked by restrictive measures imposed by the U.S. on China's access to advanced AI technologies and semiconductor manufacturing equipment. These restrictions have inadvertently sparked a wave of innovation among Chinese tech companies, prompting them to develop alternative solutions to overcome technological barriers. DeepSeek's success exemplifies how Chinese firms are leveraging domestic resources and talent to drive innovation despite geopolitical tensions. The company's open-source approach to AI development contrasts sharply with the proprietary models favored by its U.S. counterparts, further positioning it as a leader in the sector. Industry perspectives. Various industry sources have noted the implications of DeepSeek's innovations. For instance, analysts from the South China Morning Post have highlighted a shift in investor sentiment towards China's tech sector, recognizing the competitiveness of private sector innovation in the face of traditional government-backed initiatives. Meanwhile, technical scrutiny from platforms like Sourceability raises questions about the transparency of DeepSeek's GPU utilization claims, emphasizing the need for independent verification of its training processes. The Diplomat has observed that DeepSeek's emergence may lead to a technological bifurcation between the US and China, with both superpowers striving to accelerate their respective R&D investments and establish alternative supply chains. Future prospects. As DeepSeek continues to challenge established players in the AI space, the implications for the semiconductor industry and global AI markets are profound. The company's focus on cost-effective solutions and an open-source model is likely to encourage further innovation and competition, potentially reshaping the landscape of AI development. Moreover, the creation of 300 new jobs signals not only DeepSeek's commitment to growth but also its role in fostering a robust ecosystem for semiconductor innovation in China. This development may inspire other tech firms to pursue similar strategies, ultimately driving the industry towards greater efficiency and technological advancement. Conclusion: DeepSeek's bold move to create 300 new jobs in the semiconductor sector is a testament to its strategic vision for AI innovation. By investing in local capabilities and fostering a skilled workforce, DeepSeek is positioning itself as a key player in the global AI landscape. As it continues to navigate the complexities of U.S. China tech relations, the company's trajectory will be closely watched by industry stakeholders, policymakers, and competitors alike. The interplay between technological advancements and geopolitical factors will undoubtedly shape the future of both U.S. and Chinese tech enterprises in the years to come. The emergence of DeepSeek and its R1 large language model (LLM) represents a significant shift in the landscape of artificial intelligence and semiconductor technology, particularly within the context of U.S. China relations. Here are some counterintuitive insights drawn from the developments surrounding DeepSeek. 1. Cost reduction versus quality perception. The substantial cost reduction associated with DeepSeek's R1 model, being 20 to 50 times cheaper than OpenAI's offerings, could be perceived as indicative of lower quality or capability. However, the model reportedly matches or even exceeds the performance of its more expensive counterparts. This challenges the long-standing assumption that higher costs correlate with superior technology, suggesting that innovation can emerge from efficient resource utilization rather than simply increased investment. 2. Geopolitical tensions fueling innovation. The restrictive measures imposed by the U.S. government on Chinese tech companies are typically viewed as efforts to curb China's technological progress. However, these same restrictions have inadvertently spurred innovation within China as companies like DeepSeek adapt and find ways to thrive despite limited access to advanced technologies. This counters the narrative that sanctions and export controls can effectively stifle a nation's technological ambitions. 3. Open source as a competitive strategy. DeepSeek's decision to adopt an open-source model stands in stark contrast to the proprietary approaches favored by many U.S. tech giants. This strategy not only fosters collaboration and rapid innovation but also positions DeepSeek as a potential disruptor in an industry that has increasingly leaned towards closed ecosystems. The counterintuitive implication here is that openness, often viewed as a vulnerability, can instead serve as a robust competitive advantage. 4. Investor sentiment and perception of Chinese innovation. The initial skepticism towards Chinese tech innovation is shifting, as evidenced by the rapidly changing investor sentiment following DeepSeek's success. The narrative that Chinese tech companies primarily rely on state support is being challenged by the recognition of achievements stemming from private sector efficiency and innovation. This suggests a paradigm shift in how global investors view the potential of Chinese technology firms, moving from a perception of risk to one of opportunity. 5. Efficiency and resource utilization versus traditional norms. Critics of DeepSeek argue that its claims regarding GPU utilization lack transparency and may be unsustainable. However, if DeepSeek indeed operates efficiently with fewer resources, it poses a challenge to the traditional model where extensive hardware investment has been seen as necessary for success in AI development. The potential for high-quality output with fewer resources contradicts the established norms of the industry, where more extensive infrastructure has been the standard. 6. The Jevons paradox in AI development. The discussion around DeepSeek's low-cost model raises the specter of the Jevons paradox, where increased efficiency leads to greater overall demand. While DeepSeek's model is currently cheaper to train and use, the potential for increased demand for AI capabilities could lead to rising costs in the long run, countering the benefits of initial efficiency gains. This highlights the complexity of market dynamics, where technological advancement can lead to unexpected increases in resource consumption. 7. Bifurcation of global tech ecosystems. The rise of DeepSeek may signal the beginning of a more pronounced bifurcation between US and Chinese tech ecosystems, with each side developing parallel innovations that may not interoperate effectively. This fragmentation is counterintuitive to the idea of a globalized tech landscape, as geopolitical tensions push countries towards self-sufficiency and localized development strategies. The implications are profound, suggesting a future where technological advancements are heavily influenced by national policies rather than purely market forces. 8. The role of local governments in tech innovation. The support that DeepSeek has received from the Zhejiang provincial government illustrates the critical role local governance can play in fostering innovation. This challenges the notion that significant technological breakthroughs must come from established, large state-owned enterprises or heavily government-funded initiatives. Instead, it points to the effectiveness of nurturing local talent and startups in a conducive regulatory environment. In conclusion, DeepSeek's emergence as a formidable competitor in the AI sector challenges several established assumptions about cost innovation and the interplay between geopolitical dynamics and technological advancement. The company's success underscores the potential for disruptive innovation to arise from unexpected sources, particularly in times of heightened competition and regulatory constraints. In the report about DeepSeek's bold move in the semiconductor sector and its creation of 300 new jobs to fuel AI chip innovation, several critical aspects may be overlooked by readers. These elements hold significant implications for the tech landscape, particularly in the context of the ongoing U.S. China tech rivalry. 1. The importance of cost efficiency. DeepSeek's R1 model is noted for being 20 to 50 times cheaper than its U.S. counterparts, which is a crucial point that might be underappreciated. The significance lies in the potential disruption of the existing market dynamics dominated by established players like OpenAI and Nvidia. This cost efficiency signals a shift in the operational model of AI development, indicating that high-quality AI can be produced without the exorbitant costs traditionally associated with it. The importance of cost efficiency cannot be overstated, as it democratizes access to advanced AI technologies. Smaller companies and startups which may have been priced out of the market due to high costs can now leverage DeepSeek's models to innovate and compete. This could lead to a surge in AI applications across industries, ultimately fostering a more competitive and diverse market. 2. Open source approach. DeepSeek's commitment to an open source model is another critical yet potentially overlooked aspect. In an industry where proprietary technologies often dominate, this shift encourages collaboration and rapid innovation. The ability for developers to modify and commercialize DeepSeek's AI models fosters a culture of experimentation and adaptability, which could lead to faster advancements in AI capabilities. The significance of this approach lies not only in the immediate benefits for developers but also in the long-term implications for the tech industry as a whole. Open-source models can create ecosystems of shared knowledge and resources, promoting a competitive landscape where the best ideas can flourish regardless of their origin. This contrasts sharply with the U.S. firms that have largely moved towards closed systems, potentially stifling innovation through restrictive practices. 3. Geopolitical context and policy implications. The geopolitical context surrounding DeepSeek's rise is another layer that may not receive adequate attention. U.S. export controls on AI technologies and semiconductors have inadvertently spurred innovation in China, as local companies like DeepSeek are compelled to find creative solutions within the constraints imposed on them. This paradox highlights how external pressures can catalyze domestic advancements, reshaping the competitive landscape. This dynamic is significant as it illustrates the resilience of Chinese tech firms and their ability to innovate under restrictive circumstances. The implications extend beyond the immediate tech competition. They raise questions about the effectiveness of U.S. policies aimed at curbing China's technological growth. If these policies continue to drive innovation in China, they could ultimately backfire, leading to a more robust and competitive Chinese tech sector that challenges U.S. dominance. 4. The role of local government support. The support from the Zhejiang provincial government for DeepSeek and other tech startups is a noteworthy factor that could be overlooked. This backing is not just about financial assistance, it reflects a strategic vision for the region to become a global hub for AI and frontier technologies. The ambition to achieve a combined computing capacity of at least 100 EFLOPS by the end of 2025 underscores a concerted effort to position Zhejiang as a leader in the tech space. The significance of local government support lies in its potential to create an environment conducive to innovation. By fostering collaboration between the tech community and government, Zhejiang is setting a precedent for how regional policies can shape the future of technology. This could serve as a model for other regions looking to enhance their tech ecosystems, highlighting the crucial role of government in driving industry growth. 5. Impact on the semiconductor industry. DeepSeek's advancements are poised to have profound effects on the semiconductor industry, particularly as it relates to the supply chain and demand for GPUs. If DeepSeek's models can perform comparably to existing solutions with significantly lower resource requirements, it raises critical questions about the sustainability of current manufacturing practices and the reliance on high-cost components like Nvidia's GPUs. The implications for the semiconductor industry are substantial. If demand shifts towards more cost-effective solutions, manufacturers may need to reconsider their production strategies and supply chain dependencies. This could lead to a re-evaluation of which companies are able to thrive in a changing landscape, potentially altering the hierarchy of power within the semiconductor market. Conclusion. DeepSeek's emergence is not merely a story about a new AI model, it encapsulates broader themes of innovation, competition, and geopolitical dynamics. The cost-efficiency open-source approach, local government support, and the implications for the semiconductor industry are all critical elements that deserve attention. As the tech landscape continues to evolve, understanding these factors will be essential for anticipating future developments and their impact on global technology markets. Ignoring these intricacies could lead to a narrow interpretation of the significance of DeepSeek's achievements, overlooking the transformative potential they hold for the industry at large. 1. Cost efficiency and market disruption. DeepSeek's one large language model has been heralded for its unprecedented cost efficiency, offering services that are 20 to 50 times cheaper than comparable models from established U.S. companies like OpenAI. This shift disrupts the existing market dynamics, particularly affecting companies like Nvidia, whose stock prices fell sharply following the announcement of DeepSeek's model. This development raises critical questions about the sustainability of high-cost AI models and the potential for a price war in the AI sector, which could democratize access to advanced AI technologies. 2. Open-source approach and innovation. DeepSeek's decision to adopt an open-source model contrasts sharply with the proprietary strategies of its competitors. This openness not only fosters collaboration and transparency within the tech community but also accelerates innovation by allowing users to modify and commercialize the R1 model. The implications of this approach could lead to a significant shift in how AI technologies are developed and shared, potentially creating a more vibrant and inclusive ecosystem for AI advancements. 3. Geopolitical implications and U.S. China tech tensions. The rise of DeepSeek is set against the backdrop of escalating tech tensions between the U.S. and China, with U.S. restrictions on semiconductor exports inadvertently prompting innovation within China. The situation reflects a broader struggle for technological supremacy, where U.S. policies aimed at hindering Chinese advancements may be catalyzing a more aggressive push for self-reliance and innovation in Chinese tech. This dynamic reshapes the competitive landscape, suggesting that geopolitical factors will continue to influence technological progress and market strategies on both sides. 4. Provincial support and ecosystem development. The provincial government's backing in Zhejiang demonstrates a strategic commitment to fostering a robust tech ecosystem. With plans to enhance computing capacity and support for AI industries, Zhejiang is positioning itself as a global hub for innovation. This local government initiative underscores the importance of supportive policies in nurturing tech startups and fostering an environment conducive to technological breakthroughs. The success of DeepSeek may serve as a catalyst for similar initiatives across China, potentially shifting the focus of innovation from state-owned enterprises to dynamic private sector players. 1. The rise of IBM's Deep Blue 1997. In the realm of artificial intelligence, one of the most significant historical events occurred when IBM's Deep Blue defeated world chess champion Garry Kasparov. This event was not just a pivotal moment for AI but also represented a bold move by IBM to showcase its computational power and AI capabilities. As Deep Blue utilized advanced algorithms and immense processing power, it marked a significant leap in understanding how machines could outperform humans in complex cognitive tasks. The victory prompted widespread discussions about the implications of AI and its potential to surpass human intelligence, similar to the current discourse surrounding DeepSeek's advancements in AI chip development. 2. The development of the Internet. 1990s. The late 20th century witnessed the rapid evolution of the Internet, which transformed the global economy and communication landscape. Companies like Netscape and Amazon emerged during this period, revolutionizing how businesses operated online. Much like DeepSeek's innovative approach in the semiconductor sector, these companies harnessed technology to create cost-effective and accessible solutions, reshaping industries. The competitive dynamics of the Internet era also echo the current tensions between U.S. and Chinese tech firms as nations grappled with the implications of a connected world and the need for domestic technological innovation. 3. The race to the moon. 1960s. The space race, particularly the United States' push to land a man on the moon, serves as another historical parallel. This intense competition between the U.S. and the Soviet Union spurred remarkable advancements in technology, engineering, and science. NASA's Apollo program required unprecedented collaboration across various sectors. Much like the current collaboration among Chinese tech firms driven by the need to innovate in the face of U.S. restrictions on technology exports. The geopolitical context of the space race, with its focus on national pride and technological prowess, mirrors the current U.S. China tech rivalry, where advancements in AI and semiconductors are seen as critical to national security and economic competitiveness. Future outlook, predictions for the semiconductor sector and AI chip innovation. Overview. The emergence of DeepSeek and its R1 large language model (LLM) has not only disrupted the AI landscape but also catalyzed significant changes in the semiconductor industry. As we look to the future, several key trends and predictions can be drawn from the current developments, particularly concerning job creation, market dynamics, and geopolitical implications. 1. Job creation and economic growth. DeepSeek's announcement of 300 new jobs in the semiconductor sector signifies a broader trend where tech companies are increasingly investing in domestic talent and infrastructure. This is expected to lead to several outcomes. Increased employment opportunities. As companies like DeepSeek expand, the semiconductor sector will likely see a substantial increase in job opportunities across various functions, including R&D, manufacturing, and supply chain management. Skill development and education. With the rise of AI and semiconductor technologies, there will be a growing need for specialized education and training programs. Partnerships between tech firms and educational institutions could emerge, focusing on upskilling the workforce to meet industry demands. 2. Market dynamics and pricing strategies. DeepSeek's cost-effective AI solutions have set a precedent that could redefine pricing strategies across the semiconductor industry. Competitive pricing pressures. As DeepSeek's models are significantly cheaper to deploy than their American counterparts, competitors will be pressured to re-evaluate their pricing models to maintain market share. This could lead to a price war in the AI sector, stimulating further innovation and efficiency. Increased investment in R&D. The competitive landscape will incentivize companies to invest more in R&D to create next-generation chips that can deliver higher performance at lower costs. This innovation cycle will likely drive technological advancements in semiconductor manufacturing processes. 3. Geopolitical implications. The U.S. China tech rivalry will continue to shape the semiconductor and AI landscapes. Innovation in response to restrictions. As U.S. export controls on advanced semiconductor technologies persist, Chinese firms like DeepSeek will likely accelerate their innovation efforts, fostering a self-reliant tech ecosystem. This could result in breakthroughs that allow China to compete effectively on the global stage. Bifurcation of technology ecosystems. The rise of parallel tech ecosystems, one dominated by U.S. companies and the other by Chinese firms, could lead to a fragmented global tech landscape. This bifurcation may affect international collaboration, supply chains, and the overall pace of innovation in the semiconductor sector. 4. Evolution of semiconductor supply chains. The semiconductor industry will undergo significant transformations in its supply chain strategies. Diversification of suppliers. Companies may seek to diversify their supply chains to mitigate risks associated with geopolitical tensions. This could lead to increased partnerships with semiconductor manufacturers in other regions such as Southeast Asia or Eastern Europe. Localized production. As companies prioritize self-sufficiency, there will be a push toward localized production of semiconductor components. This strategy could enhance resilience against supply chain disruptions and reduce dependency on foreign suppliers. 5. Technological advancements. The advancements in AI and semiconductor technologies will continue to propel the industry forward. Increased efficiency and performance. The drive for cost-effective AI solutions will lead to advancements in chip architecture, enabling higher computational performance with reduced energy consumption. This trend will be crucial for the sustainability of AI technologies. Open source innovations. DeepSeek's open source approach may inspire a wave of collaborative innovations in the semiconductor space. This could lead to faster development cycles and greater accessibility of advanced technologies for smaller firms and startups. 6. Future market size and opportunities. The semiconductor market, projected to exceed $1 trillion, will present numerous opportunities. Emergence of new startups. The success of companies like DeepSeek will likely encourage a new wave of startups focusing on AI and semiconductor technologies. This influx of innovation will foster a vibrant ecosystem that can respond quickly to market needs. Investment surge. Increased interest in AI will attract investment from venture capitalists and institutional investors, further fueling growth and innovation in the semiconductor sector. Conclusion. The future of the semiconductor industry and AI chip innovation is poised for significant transformation, driven by competitive pressures, geopolitical factors, and technological advancements. Companies like DeepSeek are not only reshaping market dynamics but also paving the way for a new era of innovation. As the industry evolves, the interplay between cost efficiency, talent development, and geopolitical realities will be crucial in determining the trajectory of both the semiconductor sector and the broader technology landscape. The prospects for job creation, economic growth, and global competitiveness are promising, making this an exciting time for the tech industry.